Hey everyone, and welcome back to the Deep Dive. So
So,
today, we're going to be diving deep into something pretty amazing, the Model Context Protocol, or MCP. You know, it's changing how large language models interact with the world around them. Like, those really smart AI systems. You ready to jump in?
Absolutely. And get this, imagine your LLMs, like just smoothly pulling data from your own files, digging into databases, even controlling those external systems, all while staying super secure and under your control. That's the power that MCP brings to the table.
Okay, so it's like
Yeah.
giving my LLM a backstage pass to all sorts of information and tools. That's wild. Oh,
But how does it all work? From what I've gathered, MCP uses a client-server architecture. But what does that really mean, like in this context?
yeah, it's actually a pretty clever system. So you have these clients, think of them like messengers, acting as go-betweens
Yeah.
for the host, which is your LLM application,
Okay.
and the servers, which hold all the functionality and data.
So is it kind of like my web browser? The client connecting to a website server. Exactly. The browser asks for info, and the server delivers. But here's the cool part. With MCP, the information isn't just web pages. It could be anything. Files, database records, even real-time data from your system. And that separation between client and server is what makes MCP so flexible.
Wow, that opens up a ton of possibilities. So these servers, could they be running on my own machine or even remotely somewhere else?
You got it. It gives you options for different situations. Take Claude Desktop, for instance. It's a popular LLM application. And it uses MCP to tap into local servers, letting it access your local files and resources right on your computer.
That's incredible. So we have this client server set up,
Yeah.
but how do they actually talk to each other? I noticed something about a transport layer and a protocol layer. What's the deal with those?
Good eye. The transport layer handles the nitty-gritty details of moving data around. Think of it like the roads and highways for information. MCP offers two main options: Studio Transport, which is super efficient for local communication, and HTTP with SSE Transport, which is more versatile. For remote setups and real-time updates,
So choosing the right transport depends on whether I'm working on my own machine or connecting to something far away.
Yeah.
It's like picking the best route for your road trip.
exactly. And no matter which road they take, all MCP messages use JSON RPC 2.0. It's a consistent format for exchanging information, which keeps things running smoothly no matter what.
Smart. It's like having a universal language for all this back and forth communication.
Yeah.
Okay, so we've got the transport figured out, but what about the actual messages themselves? What kinds of conversations are happening between the client and server?
Well, it's like a well-choreographed dance. There are four main message types that make up this communication framework: requests, notifications, results, and errors.
Okay, break it down for me. What's a request? Sounds pretty self-explanatory.
Imagine the client saying, "Hey, server, I need this specific piece of data." Like that. Request. And the server, always the polite one, replies with either a result, if everything goes smoothly, or an error, if something goes wrong.
Makes sense. And what about those notifications you mentioned? Are those like friendly updates, like texting your friend, hey, I'm on my way?
That's a perfect analogy. Notifications are one-way messages, no reply needed. They keep everyone in the loop about events or status changes. But now, let's get to the heart of it all. The data itself, that's where resources come in.
Yeah, resources.
Mm-hmm.
From what I've read, it seems like they're the key to accessing all sorts of data. And the variety is mind-blowing. Files, database records, even live system data. It's like MCP has a universal adapter for information.
And each resource, just like a web page, has its own unique address, is identified by a unique URI. This keeps everything organized and lets the client easily find what it needs. No more searching for a needle in a haystack.
Okay, that's super organized. But if I'm the LLM, how do I even know what resources are out there? Is it like browsing a giant catalog?
Not quite. MCP has two clever ways. For clients to discover resources, servers can directly provide a list of what's available. But for situations that need more flexibility, there are resource templates.
Resource templates. What are those?
Think of them like blueprints that let you construct the exact URI you need. For instance, you could request logs for the past hour or sales data for region X, all dynamically generated on the fly.
That's amazing. It's like having a custom-made data request system, but with all this access to potentially sensitive information. Security's got to be a top priority.
Right. Absolutely. And MCP doesn't take security lightly. It's built with a multi-layered approach to protect your data and make sure everything runs smoothly. We can delve into the specifics later, but rest assured, security is a core part of the MCP philosophy.
Okay, that's reassuring to hear. So we have these resources, but how do we guide the LLM to use them effectively? Is it like giving it a set of instructions?
You're on the right track. That's where prompts come in. They are reusable templates, almost like cheat sheets for your LLM that can be customized with dynamic arguments.
I love that analogy. It's like Mad Libs for LLMs. You provide the structure. The LLM fills in the blanks with specific information.
Exactly. And these prompts can do some pretty amazing things. They can incorporate context from resources, giving the LLM more information to work with, and can even be chained together to guide multi-step workflows.
So it's not just single commands, but entire sequences of actions, all guided by these prompts. And I've even seen them appear as familiar UI elements, like /commands. That makes them really user-friendly.
Excellent observation. That's a key part of MCP, making it accessible for developers and users alike. You even have control over which prompts are used and how. But what if you want LLMs to do more than just process text? What if you want them to actually take action in the real world?
That's where those tools we briefly mentioned come into play.
Right.
Imagine an LLM that can run commands, interact with APIs, even analyze data from spreadsheets. It's like giving them a toolkit for problem solving.
You got it. Tools allow LLMs to become active participants, not just passive observers. But it's important to understand the difference between tools and resources. Resources provide the data, while tools take action based on that data.
So, if resources are ingredients, tools are the appliances that use them to create something new. I like that. But how does an LLM know how to use a particular tool correctly?
When invoking a tool, there's a structured definition with names, descriptions, and input schemas. Think of it as a set of instructions that ensure the LLM provides the correct input, preventing any miscommunication.
It's like each tool comes with its own user manual, making sure the LLM knows exactly how to operate it. And I noticed that tools are model controlled, which means the LLM has more autonomy. That seems pretty powerful.
Yeah.
But is it safe?
That's a great question, and we'll dive deeper into the safety mechanisms in a bit. But before we get there, there's one more mind-blowing concept we need to discuss: sampling. This feature allows servers to actually request completions from LLMs, almost like having an AI agent working for you.
Whoa, hold on. LLMs completing tasks on their own. That sounds like something straight out of a sci-fi movie. Tell me more.
Sampling is like giving your LLM a mission and letting it figure out the best way to accomplish it. Imagine you're stuck writing an email. And with sampling, your LM could analyze previous emails and draft a response for you, almost like an AI assistant working behind the scenes.
Wow, that's incredible. But doesn't that raise concerns about LLMs going rogue, making decisions without human oversight?
It's a valid concern, and that's why MCP has built-in safeguards to ensure responsible use. The sampling process involves multiple steps, each with human-in-the-loop controls. The server sends a request to the client, which can be reviewed and modified before it even reaches the LLM. And once the LLM generates a completion, the client can again modify or reject it before sending it back to the server.
So it's like a carefully choreographed dance
Between
the server, client, and LLM, and the human conductor, making sure everything stays in harmony.
Precisely. It's all about balancing the power of LLMs with human control and ethical considerations. Now, remember those security measures we touched upon earlier? Let's dive into those a bit deeper, because security is paramount when dealing with powerful tools like LLMs.
Okay, let's unpack those security measures. You mentioned a multi-layered approach. So what's the first line of defense?
Well, think about it like this. When clients and servers are communicating, especially over a network, it's crucial to protect that data in transit. It's like putting those important messages in a secure, locked box before sending them across the internet.
Makes sense. So how does MCP handle that?
MCP recommends using TLS for remote connections. It's a way to encrypt the communication, making it much harder for anyone to eavesdrop or tamper with the data. But security isn't just about protecting data while it's traveling. It's also about making sure only authorized parties can access it in the first place.
So it's like having a digital bouncer at the door, checking IDs to make sure only the right people get in.
You got it.
Yeah.
That's where authentication comes in. MCP allows for implementing authentication mechanisms, which are essentially ways to verify the identity of clients and servers. This helps prevent unauthorized access and ensures that only trusted entities can interact with each other. No more crashing the party without an invitation.
I like that analogy. But what about those sneaky attackers who might try to sneak in malicious code disguised as harmless messages? Is there a way to catch those?
Absolutely. MCP stresses the importance of message validation. It's like having a security scanner that carefully inspects every incoming message. It makes sure the message conforms to the expected format and doesn't contain any harmful elements that could compromise the system.
So it's like a thorough inspection to make sure nothing dangerous is slipping through the cracks. That's reassuring.
And it goes even further. It involves sanitizing inputs, which means removing any potentially dangerous characters or sequences that could be used to exploit vulnerabilities. It also includes checking for message size limits to prevent the system from being overwhelmed by massive, bogus messages.
Wow, that's a pretty comprehensive approach to message security. But what about the actual data? The resources that LLMs are trying to access? How are those protected?
Remember how we talked about resources being application controlled? Well, that control extends to security as well. Servers can enforce strict access controls, determining which clients can access which resources and what they're allowed to do with them. It's like a librarian carefully guarding valuable books, granting access only to those with proper permissions.
That makes a lot of sense. So it's not just about securing the communication channels, but also about protecting the information itself.
Precisely. This access control can even be very granular, allowing servers to define specific permissions for reading, writing, or modifying resources. This means that even if an attacker somehow gained access to the system, their actions would be limited by these predefined rules.
It's like having multiple layers of security, each one reinforcing the others. But what about those attackers who try to brute force their way in, bombarding the server with requests until it collapses?
Good point. That's where rate limiting comes in. It's a common technique to throttle the number of requests a client can make within a certain time frame. Think of it as a speed limit on the information highway.
That prevents anyone from hogging the lanes and ensures everyone has fair access.
Clever. Are there any other security measures in place?
Absolutely. To stay ahead of potential threats, MCP encourages auditing resource access. This means keeping detailed logs of who accessed what and when, providing valuable insights for detecting any suspicious activity.
So it's like having a security camera recording everything, just in case you need to review the footage later.
Exactly. And to protect against more sophisticated attacks, like those tricky attempts, to access files outside the intended directory. MCP recommends thorough path sanitization. It's like having a digital map that keeps everyone on the designated path.
Okay, that's really impressive. But all this talk about security makes me wonder, what happens if something does go wrong? Even with all these measures, errors can still occur.
Right. Of course. And MCP addresses this head-on with its robust error handling mechanisms. Okay, let's switch gears then and talk about error management in MCP. What are some key principles to keep in mind?
Transparency and clarity are paramount. When errors happen, it's not about hiding them, but about providing clear and informative feedback.
So, no more cryptic error messages that leave you scratching your head. I like that. What kind of information is usually included in these error messages?
MCP has a standardized set of error codes that cover common scenarios, like invalid requests or internal server errors. Each code comes with a clear explanation, giving both developers and users a better understanding of what went wrong.
So, it's like a dictionary of errors, with each entry providing context and potential solutions. That's incredibly helpful.
And here's where MCP's flexibility shines again. Developers can go beyond these standard codes and define their own custom errors, specific to their application or server. This allows for a more tailored and precise approach to error handling.
That makes a lot of sense. But what about preventing sensitive information from leaking out in these error messages? Could that pose a security risk?
Absolutely, and MCP strongly advises against it. Sensitive information should always be logged internally for investigation, keeping it hidden from prying eyes. Public-facing error messages should remain discreet, providing just enough information to understand the issue without compromising security.
So, it's like having a secret logbook for sensitive security events, while keeping the public error messages vague enough to protect confidential data. Smart.
And remember, when errors occur, it's crucial to have procedures in place to clean up and release any resources that were acquired during the failed operation. This helps maintain system stability and prevents any potential resource leaks that could lead to further problems down the line.
So, it's not just about conveying the error message, but also about making sure the system recovers gracefully and stays secure, even when things go wrong.
Exactly. Error handling and resource cleanup go hand in hand. And to further enhance robustness, MCP emphasizes having mechanisms to handle those dreaded denial-of-service attacks, where attackers try to flood the system with requests.
That sounds like a crucial defense mechanism. How does MCP handle that?
Well, Think of it like having a digital floodgate that can be closed. To prevent the system from being overwhelmed, it's a way to control the flow of incoming requests and protect the server from being overloaded.
Wow. It sounds like MCP has really thought of everything when it comes to security and error management.
Security is an ongoing process,
Yeah.
and MCP provides a solid framework for developers and users to build secure and reliable LLM applications. But even with the most robust safeguards in place, staying vigilant, following best practices, and keeping up to date with the latest security updates is crucial.
Okay, so it's a shared responsibility to keep everything running smoothly and securely. We've talked a lot about the safeguards, but I'm curious about how typical interaction between a client and server
Yeah.
actually plays out. What are the key stages involved?
It's like a well-defined dance, with specific steps, ensuring that communication between the client and server is orderly and reliable. It all starts with the initialization phase.
Initialization, what happens there?
It's essentially like a handshake, where the client and server introduce themselves and exchange essential information.
Okay, so they're setting the ground rules for the conversation.
Exactly. The client sends an initialize request to the server, outlining the protocol version and the capabilities it supports. The server responds in kind, sharing its own protocol version and capabilities. Once the client receives this information, it sends back an initialized notification to confirm that it's ready to proceed.
Okay, so once the pleasantries are out of the way, what happens next?
That's when we enter the message exchange phase, the heart of the interaction. This is where the client server can freely communicate, sending and receiving those requests, responses, and notifications we talked about earlier.
So it's like an ongoing dialogue, with each party following the established protocol to keep the conversation flowing smoothly.
Precisely. You can think of it as a carefully choreographed dance, with each party knowing their steps and responding appropriately to keep everything in sync.
I love that analogy. But like any good dance, there comes a time to gracefully bow out. How does the connection between the client and server eventually come to an end?
There are a few ways the connection can be wrapped up. The ideal scenario is a clean shutdown, where either the client or server initiates a controlled disconnection. It's like saying goodbye before hanging up the phone. It gives both sides a chance to finish up any ongoing tasks and release resources in an orderly way.
So, no sudden interruptions or dropped connections. Everything gets neatly wrapped up. But I imagine things don't always go so smoothly in the digital world. What happens if the connection's interrupted unexpectedly?
You're right. Sometimes unexpected events happen. We call that a transport disconnection. Kind of like if the phone line suddenly gets cut off, it could be caused by a network failure or something similar.
Okay, so that's like an unplanned disconnect. Are there any other scenarios where the connection might be terminated?
Yes, in some cases. There might be a severe error condition, like a software bug or system crash, that forces the connection to close. It's a bit more dramatic, like if your phone suddenly caught fire and you had to toss it out the window.
Okay, that's a vivid image. But it sounds like MCP has ways to handle all these different situations.
Yeah.
And keep things as stable as possible.
Exactly. It's designed to be robust and resilient, able to gracefully handle both planned and unplanned disconnections.
This has been an incredible journey, exploring all these intricate details of MCP. It's truly amazing how much thought and care has gone into designing this protocol.
It's a testament to the dedication of developers and researchers who are paving the way for a future where LLMs can seamlessly and safely interact with the world around us.
From its flexible architecture and powerful capabilities to those robust security measures and thoughtful error handling we discussed, MCP is setting the stage for a new era of LLM applications. It's really exciting to think about all the possibilities.
I completely agree. With MCP, we're moving beyond simple text generation and entering a world where LLMs can become active participants in our digital lives, helping us solve problems and accomplish tasks in ways we never thought possible.
It's like giving LLMs a toolkit and a roadmap,
Yeah.
empowering them to navigate the complex world of data and actions, while keeping everything safe and under control.
Exactly. MCP is laying the foundation for a future where LLMs are not just tools, but partners working alongside us to shape a better, more efficient, and more innovative world.
Well, on that inspiring note, we've reached the end of our deep dive into the Model Context Protocol. It's been a fascinating journey, and we hope you've gained a deeper understanding of this revolutionary technology and its potential to transform the landscape of LLMs.
It's been a pleasure sharing this exploration with you.
And to all our listeners, as you go forth into the world of LLMs and MCP, remember to stay curious, keep exploring, and always dive deep into the technologies that are shaping our future. Thanks for joining us on the Deep Dive.